Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this word problem using the concepts of derivatives. So as per the problem, a 75-liter gas tank has a leak. After T hours, the volume remaining V in liters, V at T equals 75 parentheses 1 minus T over 24 square, where T is between 0 and 24. And we have to use the product rule to determine how quickly the gas is leaking from the tank when the tank is 60% full of gas. Now this function V at T is made up of a constant 75 times 1 minus T over 24 square. So for the derivative of this function, we don't have to use product rule because this function is not made up of two functions because the first term is just a constant. So we can also use just power rule to find the derivative of this function v. Now the first step in this problem is to find the time when the tank is 60% full of gas. So we know that the capacity of the gas tank is 75 liters. So the first step is to find the value of T for 60% of 75. So we'll sub in V at T as 0.6 times 75 equals 75 parentheses 1 minus T over 24 square, because we have to find T, because in order to find the rate at which the volume is changing at a particular time T, we need to know the value of T, because we'll be using that value of T to find the rate of change for volume at that point in time. So first let's simplify the left side. So 0.6 times 75 is equal to 45. So we get 45 equals 75 parentheses 1 minus T over 24 and square. Now we can simplify this equation by dividing both sides by 75. So the 75s on the right side cancel each other out, and on the left side we do 45 divided by 75, which is equal to 0.6 equals 1 minus T over 24 square. Now we can apply square root to both sides. So the square and the square root on the right side cancel each other out. Now square root of 0.6 is equal to 0.7746 equals 1 minus T over 24. Now we can subtract 1 from both sides. So the ones on the right side cancel each other out. And now we get, so on the left side we do 0.7746 minus 1. So we get negative 0.2254 equals negative T over 24. Now we can get rid of the 24 by multiplying both sides by 24. So the 24s on the right side will cancel each other out, and on the left side we do negative 0.2254 times 24, which is equal to negative 5.4096 equals negative T. Now we can divide both sides by negative 1. So both sides become positive. So we get T equals 5.4096 and the unit is hours. So that means after 5.4096 hours, the volume in the tank becomes 60% of the initial volume, which is 75 liters. Now we have to find the rate of change for V at this time t. So for that we'll have to find the derivative of the given function V at t. So we can use the prime notation. So prime of V at t equals, so here we can use the power rule instead of the product rule. So the 75 is a constant that stays as it is. So now we'll use the power rule. So we get 2 and then parentheses 1 minus t over 24 exponent 2 minus 1 times the derivative of the inner function, which will be 0 minus 1 over 24. So 1 is a constant, so that's why its derivative is equal to 0. Now we can sub in t as 5.4096 because that's the time at which we have to find the rate of change. So we get prime of v at 5.4096 equals, so 75 times 2 is 150 times 1 minus 5.4096 over 24 and then exponent 1, but we don't write 1 as an exponent, and then times. So 0 minus 1 over 24 is just minus 1 over 24. Now we have to simplify this expression. So we get prime of v at 5.4096 equals, so we do 150, and now we can simplify the expression in the parentheses. So we do 5.4096 divided by 24, which is equal to 0.2254 times negative 1 over 24. And now we can simplify this expression further. Equals 150 times, so we do 1 minus 0.2254, which is equal to 0.7746 times negative 1 over 24. Now we can multiply these terms together using our calculator. Equals, so 150 times 0.7746 times negative 1 divided by 24. So I got negative 4.84 liters per hour. So this should be the final answer for the rate at which the gas is leaking from the tank when the tank is 60% full. And we got a negative answer because the volume is decreasing at the rate. And we used liters and hours for the answer, for the unit of the answer, because those are the given units in the problem. So these are the steps you have to keep in mind to solve a problem like this one. So the first thing we need to do here is to find the time at which the volume in the tank will be 60% of the full tank capacity, and then we use that time to find the rate of change, and here we use the power rule instead of the given product rule. But if you use the product rule, you'll get the same answer. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.